These are the Lesson 9.5 notes on adding and subtracting rational expressions. That is our focus for today. We're also going to simplify what are called complex fractions. And we want to start with the idea that when you're working with rational expressions, just like fractions, when you add and subtract fractions, what we have to find are common denominators. These common denominators are also known as the least common multiples. Now, if you were adding a fraction that had a denominator of x squared minus 4 to another fraction that had a denominator of x squared plus 5x plus 6, what we're going to do first is we're going to factor these into what are called the prime factors. Now, x squared minus 4 is our difference of squares. We know that factors into x minus 2 and x plus 2. For the expression x squared plus 5x plus 6, we know that this would factor into the expression x plus 2 times x plus 3. Now, to find what's called the common denominator or the least common multiple, we're going to write each prime factor the greatest number of times it appears in either expression. Now, in this case right here, there is an x minus 2. I'm going to cross that off because I'm done with it. We have an x plus 2 here as well, which is also here. So x plus 2 appears once in each of these. So we're going to cross it off here as well because we've used it already. There's still an x plus 3 left over, and this is called the least common multiple. Let's try another example. For the second problem with 12x plus 9 and 4x squared minus 5x minus 6, you can factor a 3 out of the first term, and you're left with 4x plus 3. Now, I've talked about how to go about solving this type of problem where you're looking for two numbers whose product is a times c, which would be negative 24, and whose sum is negative 5, the number in the middle. The two numbers we're looking for here are negative 8 and positive 3. They'll replace our middle term, so we're going to have 4x squared minus 5x minus 6. Our middle term becomes negative 8x plus 3x. You can take a 4x out of the first two terms, leaving you with x minus 2. And you can take a positive 3 out of the second two terms, leaving you again with x minus 2. Because you can take an x minus 2 out of both of these terms, what you're left with is x minus 2 times 4x plus 3. Now, to answer our question, what's the least common multiple? Both of these terms have a 4x plus 3 term. There's a 3 term, and there's also an x minus 2 term. So we're going to have 3, 4x plus 3. So that takes out both of these factors. It also takes out the 4x plus 3 here. And we have an x minus 2. This would be your least common multiple. Now, we'll use that same kind of idea when we add and subtract our rational expressions over here. The first thing we're going to do is we're going to factor the denominators if necessary. The first fraction here is 4 over x minus 3. We really can't factor that denominator. However, the second fraction has x squared minus 4, which we can factor into x plus 2 times x minus 2. Write each fraction with common denominators. Here, there's no repeated factor between these. We have all unique factors, x minus 3, x plus 2, x minus 2. So our common denominator is the x minus 3 with the x plus 2 times the x minus 2. So for our first fraction, which started with a 4 right here, in order to get common denominators, we're going to have to, we've multiplied the denominator by x plus 2, so we're going to have to do the same thing with the numerator. We multiplied this denominator by x minus 2, so we have to do the same thing with this numerator. Plus, same denominator, x minus 3, x plus 2, x minus 2. Now, originally our expression had a 2x above the x plus 2 and x minus 2. What's new is this x minus 3, so we're going to multiply top and bottom by x minus 3. First step, factor. Second step, write fractions with common denominators. Third step, add and subtract the fractions. Add the numerators with one denominator. So what we have here is 4 times x plus 2 times x minus 2. We can begin to multiply this out here. I usually suggest multiplying the things that look kind of the hardest to work with, so I would do the x plus 2 times x minus 2 first. X plus 2 times x minus 2 ends up being x squared minus 2x plus 2x, those cancel, minus 4. Kind of reminds us of our difference of squares. For our second term, we have 2x that's going to get multiplied by x and negative 3. So it's going to give us 2x squared minus 6x. It's all over one denominator, which is x minus 3, x plus 2, x minus 2. And it's okay to leave that in factored form. You don't have to multiply out the denominator, but you will the numerator. Continuing this, you can continue to distribute the 4 across both of these terms in parentheses. Gives you 4x squared minus 16 plus 2x squared minus 6x with our same denominator. And finally, you can add the like terms. 4x squared and 2x squared is 6x squared minus 6x minus 16, all divided by x minus 3, x plus 2, x minus 2. And here's our final solution. We'll generally expand out the numerator and leave the denominator in this factored form. Let's try it again for the second problem. We have 1 over x plus 4 minus x plus 2 over x squared minus 16. Obviously, we can't factor out x plus 4 any further. However, we can factor out the denominator of the second fraction. It's a difference of squares. It's going to turn into x plus 4 times x minus 4. Because both of these terms have x plus 4 in the denominator, that's going to be one of our least common multiples. We also have this x minus 4 as well. So I'm going to rewrite both of our denominators. Our original denominator was just x plus 4. So what's new in this first fraction is we've multiplied the top and bottom by x minus 4. The second fraction is set already. We haven't changed the denominator at all, so you can leave this as x plus 2. One thing I will do is I will put that in parentheses for reasons that'll make sense in just a moment. Third step, we're going to add the fractions together with one denominator, so we're going to write this with a single denominator. Our numerator here is 1 times x minus 4, so that's just x minus 4. The negative sign distributes to both terms inside the parentheses, so this is negative x minus 2. And now when we add our like terms together, you'll notice that we have an x minus x, that's 0, those cancel out. We just have negative 4 minus 2, which equals negative 6. Now that we know how to simplify sums and differences of rational expressions together, what we're going to look at next is how you simplify complex fractions, which is where we have a fraction over a fraction, or some sort of value over maybe a fraction plus something else. So let's take a look at our first example. We have 3 all divided by 1 plus 1 over x. Now the number 3 is like the fraction 3 over 1. My goal is I want to have a fraction divided by a fraction, similar to the second example. Right now what I have is a number divided by a number plus a fraction. So the first value, 3, can be just written as 3 over 1. That's not a big deal. However, the denominator, this 1 plus 1 over x, I'd like to write this as a fraction instead of a number plus a fraction. So we're going to add these together. The number 1 is obviously like 1 over 1. So our common denominator is just going to be x in this case. Because if I multiply the top and bottom by x, what I'll end up with is 1x over x, or just x over x, plus 1 over x. So my numerator is 3 over 1. My denominator is now going to be, we have common denominators when we're adding these fractions, it's going to be x plus 1 over x. Now we know when you divide fractions, what we do is we flip and multiply by the second fraction. So when we have 3 over 1 divided by x plus 1 over x, that's the same thing as 3 over 1 times, take the reciprocal of this, x over x plus 1. When you multiply the numerators, we get 3x. When you multiply the denominators, this is 1 times, again, you can think of this as being in parentheses, x plus 1. So that's our denominator. For the second problem, we already have a fraction divided by a fraction. So this problem, most of the work has been done for us already. We have 1 over x plus 2 times, flip and multiply, this will be x plus 2 over 4. Again, you can put the x plus 2 in parentheses. Because these are factors, you are allowed to cancel something that's the same in the top and bottom. We can cancel out the x plus 2 here, and you're left with 1/4. Hey, that was easy. Last example. We have a fraction divided by 1 minus a fraction. So I'm okay with the 2 over x minus 3. What I am going to need to simplify, though, is the big denominator here. So it's going to be all divided by, you can think of x minus 3 as being a factor, and this is like 1 right here. So what I need to do is I need to multiply the first fraction by x minus 3 over x minus 3. And that's going to give me x minus 3 over x minus 3. And then this is minus 1 over x minus 3. Now we have the same denominators. Our original problem, an original fraction, we have 2 over x minus 3 up top. That's going to stay up there. All divided by x minus 3 is our denominator here. And we'll have x minus 3 minus 1. What this will simplify to is we still have 2 over x minus 3 up top. And it's all divided by, we have x minus 3 in the bottom. And we have x minus 3 minus 1, which is x minus 4. Now we finally have a fraction divided by a fraction. This is going to allow us to do our flip and multiply step. So we're going to have 2 divided by x minus 3 times, flip the second fraction, x minus 3 over x minus 4. And again, it's okay to have these denominators in parentheses as well as the x minus 3. Same numerator and denominator here, they can cancel these out. And you're left with 2 divided by x minus 4. There's our final solution. And this gives you an idea of how to add and subtract rational expressions as well as simplify complex fractions.